Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the ACT. We have been solving ACT math problems out of this book here, the official ACT prep guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 176. Please turn to it. Page number 176. And today is our lesson number 18. The very last problem on the page, number 53. In 53, what's going on is that we have this person who goes around asking his or her friends what their favorite colors are, and she made a list of those answers, those responses, in the form of a survey, and here are the results. 25% of her friends said that their favorite color is red. 30% of the people said that their favorite color is blue. 20% said their favorite color is green. And 10% said that their favorite color happens to be purple. Let's add them up. That's all the colors that were mentioned. Let's add them up and see what it adds up to. We have a 5 here. Then we have 2 plus 3 is 5. 5 plus 2 is 7. 7 plus 1 is 8. That's 85%. What about the remaining 15%? The remaining 15% is what we put them together, lump them together under the category of other. And the question simply is, if you were to represent this category of other on a pie chart, the slice in the circle will be what will be the angular measure? That's how we say it. What will be the angular measurement of this slice on a pie chart? What would be the angular measurement of this slice? Let's see how they say it. What will be the degree measure of the other sector? Same thing. What's the degree measure? What's the angular measurement? I like this one better because it sounds more geeky. You understand? The geekier the better. Let's find out, shall we? We're looking at pie chart. Well, pie chart, as we know, is so called because it's a circle, except not a banged up one. Let's do another one. Oh, there we go. That's a vast improvement. It's a circle, and everything, all the slices, all the different sectors are represented on the circle, and therefore the total is 100%. But because it's a circle, the degree measurement of all the slices together has to be 360. That's not 100 degrees, that's 100%. Okay. The degree measurement of all the slices is 100%, and the 100% of the circle, of course, has to be 360 degrees. We know that. So we know that 100% has to equal 360 degrees. Has to equal 360 degrees. Well, that implies that 10%, this should say 100%, not 100 degrees. I keep writing it like that. 100% has to be 360 degrees. And that implies that 10% has to be the tenth of it. A tenth of 360, you just knock out the zero. So it's 10th of 360 is 36 degrees. And if 10% is 36 degrees, then 5% would have to be half of that, and half of 36 is 18 degrees. How do we know it's 18 degrees? Well, if we divide 36 by 2, how many 2's in a 3? 3 has 1 2's, the remaining one goes and joins the 6, becomes 16. How many 2's in a 16? 16 has 8 2's, 18. That's it, we're done. 10% plus 5% is our 15%. All we have to do now is our 15%, all we have to do is just add up these two numbers. 6 plus 8 is 14, that's 4, carry 1. 1 plus 3 will be 4, 4 plus 1 is 5. It's 54 degrees. So that's one way, that was one way of figuring out what will be the degree measurement of the other sector. Another method, the more traditional method, would be to set it up as a proportion problem. If you like, we can do that too. You want to do it up as a proportion problem? More traditional way? Alright, let's do it then. Let's do it here on this side. Let's do it here on this side, so we can compare the two next to each other. In a proportion problem, we know that here is our degree, and here is our percentage. 360 degrees has to be 100%. Now once you put a degree and a percentage symbols here, once you put this degree and the percentage labels here, rather not symbols, Once you put the degree and the percentage labels here, we don't have to do the same thing here. There will be repetition. It's just 360 over 100 has to equal. And the question is, how many degrees are there in a sector that comprises 15%? That's it. And we just solve for x. That's all it is. This is more of a traditional way, as I said, setting it up as a proportion problem. All we have to do is multiply both sides by 15. When we multiply both sides by 15, this 15 we will get rid of, and will reappear. This 15 from the bottom will reappear on the top on this side. So x equals 360 over 100 times 15. Let's divide top and bottom by 10. If we divide top and bottom by 10, we can knock out this 0 with that 0. Let's divide top and bottom by 5. 15 has 3 5s, 10 has 2 5s, and let's divide top and bottom by 2. How many 2's in a 3? 3 has 1 2. The remaining one goes and joins the 6, becomes 16. How many 2's in a 16? 16 has 8 2's. There you go. As you can see, the story does not change, of course. Of course the story is not going to change. The story cannot change. The answer has to be the same at the end. Just because we are using two different methods does not mean that we're going to get two different answers. The answer has to be the same. 18 times 3 is exactly what we found here. Because the 36 here that you see there is 10% and 5% is 18. 5% is 18 degrees. So this 36 is actually 2 times 18. 36 is 2 times 18. 2 times 18 plus 1 times 18 is 3 times 18, which is exactly what we're getting here. So x equals to 18 times 3, which is 54 degrees. That was the end of that. Let's move on to the next problem on the next page. Just give me one brief second for my break, as you know. Very good. Next problem. Problem 54 on the next page. 177. We are told that the sine of theta we are told is negative 3/5. Sine of theta we are told is negative 3/5. We are also told that the theta happens to be between pi and 3 pi over 2. The question simply is, if that were to be true, then in that case, what will be the value of tangent of theta? How much is tangent of theta? Let's find out, shall we? Well, the very first thing we have to figure out is what is the degree measurement of this theta, this angular measurement of this theta. Well, what is this degree measurement? They are expressing in a radian. I don't like radians. I don't like dealing with radians. I always translate that into degrees. Makes me feel better. Well, we know that 2 pi radians equals 360 degrees. We know that. Therefore, pi radian would be 180 degrees. What we have is 3 pi over 2. 3 pi over 2 would simply be 3 times 180 over 2. Divide top and bottom by 2. 18 has 9 2's, so it's 90 times 3. 90 times 3, it turns out it is 270 degrees. So at least now we know where the theta is located. It is located somewhere between 180 degrees. It's located somewhere between 180 degrees and 270 degrees. Let's find out what quadrant that is, shall we? Let's plot it. We need the room, obviously. Where can we do it? Let's do it on this side. So this is our 0 degrees, this is our 90 degrees, this is 180 degrees. Of course it's 180 degrees because 180 degrees makes a straight line, and here is our 270 degrees. Which tells us that the theta that we're dealing with, the angle that we're dealing with, is somewhere in the third quadrant. We are in the third quadrant. And in third quadrant, as you know, both the x coordinate of a given point and the y coordinate of a given point, they are both going to be negative. So let's just throw an angle. Just throw any old angle. Here's our angle. Let's call it theta. I'm going to erase all of this thing because it's getting too crowded. We already know the answer is 54. Let me erase this thing. It's getting too crowded. I don't like it, okay? So, here's our theta. And I'm going to erase this 180 also. This is 180 degrees. And just draw a triangle, that's all. Just draw a triangle. There is your triangle. There is your triangle. Now we are told that the sign is negative 3 over 5. That's the key part, negative 3 over 5. Sine is what? Sine, of course, as you know, is opposite over hypotenuse. Since we're dealing with this theta, the opposite to that side is this side right here. That has to be negative 3. This has to be negative 3. In other words, if you were to extend this thing, this is negative 3, so it's going to be negative 2, negative 1, negative 2, negative 1. This is negative 3. This is the y coordinates here. Negative 3. Opposite over hypotenuse. And hypotenuse is this side right here. To tell you what, let's give them names so that we don't have to keep calling them this side and that side. Let's call them A, B, C. So B to C is 3. My picture is not drawn to scale, I'm warning you. And that's your opposite, that's your negative 3. That part is negative 3. And the hypotenuse is the 5. It has to be 5 because it's negative 3 over 5. The fact that top is negative 3, the bottom has to be negative 5, which of course it does. Hypotenuse cannot be negative. So it's positive 5 right here. And this is negative 3. The question is, how much is A to B? Well, A to B would have to be negative 4. Because it's a 3, 4, 5 triangle. The hypotenuse is 5, this side is 3, this side would have to be 4. This side would have to be 4 because otherwise we will have trouble with the Pythagorean theorem. The Pythagorean theorem tells us that the square of this side, which is negative 3 squared, plus the square of that side, which would have to be negative 4 squared, would have to equal 5 squared. Negative 3 squared plus negative 4 equals 5 squared, which means this side is negative 4. This side is negative 4. In other words, the x-coordinate of this point, the point C here, is negative 4. This is negative 4 and 0. This point right here is negative 3 and 0. Sorry, 0 and negative 3. 0 and negative 3, that's the y-coordinate. But anyway, we don't need that thing. Let's finish it up, shall we? We're taking too long. We find the tangent. Or where can we do it? Let's do it up here. We need the tangent. Tangent of theta is opposite over adjacent, as we know. Tangent equals opposite over adjacent. So again, this is the theta that we're talking about. The theta is this one. The opposite to the theta is this side right here, B to C, which is negative 3. And the adjacent is negative 4. So the tangent of theta is negative 3 over negative 4. And of course we can't leave it at that. We have to simplify it. The negative and negative is going to cancel each other out, and we end up with 3/4. The answer is 3/4. And that will be answer choice J. The answer is J. That's all. I do not know if I don't remember, I don't recall whether I mentioned this thing earlier or not in the beginning of the video. If I did already mention it, I'm being repetitive, I understand that in that case. This picture that you see deals with the problem that you see before that, number 52. We started out at number 53. This picture deals with number 52. If you have not watched yesterday's video, day number 17, make sure you watch that video. It's a very long video. It's about 22 minutes long because it deals with the concept of permutation and combination. If you're one of those people who has trouble with understanding the difference between permutation and combination, make sure you watched yesterday's video. Because this problem that you see there, problem number 52, for somebody who understands the concept, somebody who knows the difference between permutation and combination, problem number 52 should take no more than 10 seconds. That's it. 15 seconds, 20 seconds if you're slow. Do you understand? Not 22 minutes. Make sure you watch it and you understand the concept. Okay? I'll see you tomorrow. Okay? Bye now.